Have you ever wondered which theory won Albert Einstein the Nobel Prize? Or do you know what will happen when a light ray falls on a metal surface? There's a theory that shows light behaves not only just like a wave but also like particles. Also, this theory forms the fundamental principle behind the working of a solar panel and the image sensor. The theory I'm talking about is the photoelectric effect. Back in 1887, the German physicist named Heinrich Hertz discovered something interesting. While working with the electromagnetic waves, he noticed that the ultraviolet light made sparks in the detector loop. Well, see this photoelectric diagram, which consists of a metal plate in a glass tube and a light source. When a light of particular frequency strikes the metal surface, then the free valence electron gets ejected out from the metal surface with a certain kinetic energy. So, does this mean that I can get a handful of electrons by shining a flashlight on a steel vessel? Not quite. This is where work function or the threshold frequency comes into play. The work function is the minimum energy required to remove electron from the surface of the metal. Different metals have different work function, so they require different photons energy, and thus requires different light frequency to eject their electrons. For example, metals like steel and zinc require ultraviolet light to emit their electrons. Now, the question is, how are light rays capable of ejecting the electrons from the metal surface? This is where the Einstein arrived at the important result. He explained that light isn't just a wave, it also comes in the tiny packets of energy called photons. When these photons hit metal, they transfer their energy to the electrons, allowing them to escape the surface. Now, if the photon's energy absorbed by the electron exceeds the work function, then the electron will be emitted with the maximum kinetic energy according to the Einstein photoelectric equation. The energy of the emitted electron does not depend on how intense the light is, but on the type of the light, that is, its frequency. Increasing the light intensity increases the number of the emitted electrons per second, while the frequency of the light determines the energy of the emitted electrons. Thus, the concept of the photons and the photoelectric effect significantly contribute to the development of the quantum mechanics.